Welcome to today's deep dive. We are so glad you're joining us. Today we're examining a technical spec sheet from HDTVSupply for the Zenty ZT-433 65-inch 4K splicing LCD display. Our mission today is to cut through all that dense hardware jargon and discover the aha moments of how massive professional video walls actually function in the wild. Okay, let's unpack this.
Yeah, it's definitely a dense spec sheet to start with, but the crucial starting point is really that 3.5 millimeter bezel. I mean, when you're dealing with a physical border that microscopically thin, you are looking at near invisible seams when these giant monitors are stacked together.
Right, but just jamming massive 65-inch puzzle pieces together doesn't automatically make a seamless video wall. I noticed this unit features built-in image splicing. Does that mean it doesn't need an external processor to handle all that edge-to-edge pixel mapping?
What's fascinating here is exactly that. The physical design pairs directly with internal hardware-level splicing and dynamic white balance adjustment. So instead of relying purely on downstream software to fix the picture, the display itself calibrates light and color. It forces the whole array to act as one unified canvas rather than, just a grid of separate televisions.
And the specs on that canvas are pretty massive. We are talking UHD resolution, 16.7 million colors, and a 4,000:1 contrast ratio. But one metric really stood out to me, the 178-degree viewing angle. For a single TV in your living room, sure, that's standard. But why is that specific metric so critical when we're splicing dozens of these together?
Because if you're building a massive surveillance grid or a broadcast backdrop, the operators are rarely sitting dead center. The information has to be instantly readable from the periphery. If the image washes out or distorts for an engineer sitting off to the side, the entire multi-screen setup essentially loses its functional value.
Wow, yeah, that makes total sense. Now here's where it gets really interesting, because the source material specifically highlights those commercial use cases. We're talking about emergency command centers, intense video surveillance grids, media production. But I also saw features like anti-burn-in technology. I immediately think of my old plasma screen from 2008. Is burn-in actually still a massive problem for modern commercial displays?
That raises a really important question about operational context, and absolutely it is still a problem entirely because of the use case. In a 247 emergency command center, you have static maps and interface grids displayed relentlessly for months on end.
Right, so they literally never turn off.
Exactly. Screen burn-in or a sudden hardware failure in that environment isn't just a visual nuisance, it's a severe operational risk. That is also why the spec sheet mentions custom buttons for aging and working time recording.
I was actually going to ask about that. What exactly does aging mean in the context of monitor hardware?
It's essentially rigorous stress testing. It allows technicians to push the hardware to its absolute limits, ensuring long-term reliability before the display ever goes live in a mission-critical environment.
To run an environment like that, you clearly need heavy-duty connectivity. The interface list is loaded: HDMI, 4K, DVI, VGA, DisplayPort. But it also highlights an HDMI loop output and an RS-232 loop control. How does that loop control actually work in practice?
That is the secret to complex network integration. It's daisy chaining, basically. The RS-232 loop allows engineers to send a single command that ripples through dozens of connected screens simultaneously. You aren't managing 50 individual monitors, you're commanding them as a single entity.
The bottom line here is really about industry disruption. Seeing this commercial-grade module, packed with all these high-end integration features, sitting at a $700 price point and backed by a 5-year Zenty warranty, 60-day returns, and lifetime technical support. So what does this all mean?
Well, if we connect this to the bigger picture, it highlights how incredibly accessible high-end commercial infrastructure has become. What historically required custom engineering and exorbitant budgets can now be achieved with modular, highly reliable screens that seamlessly stitch themselves together.
It really shifts your perspective. So we will leave you with this thought. The next time you see a massive, flawless digital backdrop in a broadcast studio or a command center, take a second to consider the microscopic engineering holding it all together. Think about those 3.5 millimeter seams and invisible anti-burn-in algorithms working behind the scenes to maintain that perfect digital reality. Thanks for going on this deep dive with us.